Hello, everybody. This is Robert Hodges. I'll be one of your panelists today in our webinar on Introduction to High-Velocity Analytics using ClickHouse Arrays. This is a talk that we've been wanting to present for a long time. Arrays are a great feature in ClickHouse. We'll tell you all about them over the next hour, and I hope answer lots of questions. Before we dive into the talk, I would just like to give you a few tips about things that will help you enjoy the webinar more. So first of all, this webinar is being recorded. We're recording it right now. We will post the link to the recording as well as slides to everybody who signed up. So you don't need to take frantic notes. This will come to you in email pretty quickly. The second thing is that we do have a Q&A box which you can fill out as the webinar is running. Excuse me. And so if a question comes up, feel free to pop it into the question and answer box. If it's convenient, we'll answer it as part of the talk. Otherwise, we expect to have time at the end to answer questions. Let's see, one final thing. We do a poll at the end of every Altinity webinar. It's 3 simple questions, takes about 10 seconds to fill out. We just want to know, get some basic information to make sure the webinar is hitting the right level and help us pick future topics. So with that, I'm going to dive in. So some quick introductions. My name is Robert Hodges. Again, I'm the Altinity CEO. I've been working on databases for about 37 years this year. ClickHouse is number 20. I've had a few detours off into the fields of virtualization and security, but it's really been data for the most part over the last 3.5 decades. My colleague Alexander Zaitsev is joining me today. He's the CTO of Altinity. He has decades of experience with petabyte scale analytics systems and was actually one of the first people outside of Yandex to use ClickHouse in commercial applications. And then just a little bit about Altinity that Alexander helped found. We're the #1 enterprise ClickHouse provider. So we help make ClickHouse work for enterprises. Particularly and our focus is particularly in the United States and Eastern Europe, or excuse me, the European Union, although we have customers worldwide at this point. And as a company, we're major committers as well as community sponsors for ClickHouse throughout our main regions. And we do lots of activities. These talks are one of the ways that we help to make it possible for people to learn how to use ClickHouse effectively and be more successful with it. So enough marketing, let's dive into the talk. So for those of you that are new to ClickHouse, I'd like to just do a very quick introduction to what ClickHouse is so that you have a sense of what you're getting into. ClickHouse is an open source SQL data warehouse, and it shares some of the best features of products like MySQL. So it's well-known relational database, and Vertica, which is also a well-known data warehouse. There's actually we're not sharing any code, but we have similar features. So, and what I mean by that is that just like MySQL, we have a single binary. So there's just a single program you start and bang, you're up and running. We're open source. We run practically anywhere, and we're relatively simple to operate. So these are all characteristics of MySQL that have made it incredibly popular. ClickHouse is similar to those, very similar and in fact identical in that sense. On the other side, as we look at the analytic capabilities, we have a number of features which are similar to things that you get in products like Vertica or Snowflake or Redshift. Of course, we speak SQL language. We get that. You get that from the MySQL side of the house. Everybody knows that SQL is a great way to to process data. But more importantly, we have things like shared nothing architecture. So very efficient architecture that couples compute and storage and then links the nodes together over a network. Probably the most important analytic feature is column storage. So the data is not stored by rows, but instead is columns. So long arrays of data which are can be broken up into pieces and processed in parallel. We have vectorized query execution, which means sort of applying multiple threads to the arrays using a single instruction, multiple data, or SIMD instructions to process the arrays in chunks as quickly as possible. And then finally, very good parallelized execution across multiple nodes. So there's built-in sharding and replication, and this enables you to scale up from data sets that can run on a laptop. So for example, a few billion rows or even hundreds of billions of rows, but up to petabyte scale data sets that run on 100 servers in a data center. And then finally, the ClickHouse is just really fast, and arrays are actually a part of that. We won't be talking too much about performance today, but you can refer to some of our other webinars as well as the countless talks that people have done that discuss the speed. So let's turn from ClickHouse in general and have a look at arrays. So arrays are a SQL extension in ClickHouse. They most of the behavior that we'll be describing today, if you've not used ClickHouse before, it's things that don't really exist in most other products, and certainly ClickHouse does implements this in its own way. But there are a number of facets to arrays, and I'll just mention them here, and as we go through the talk, we will dig into them. So for example, arrays, you can look at them simply as a data type. This is an extension to tables that you can use to model certain types of data, basically anything that's a vector. There are features that allow arrays to be used in joins. We'll talk about that. There is a huge library of useful functions that operate on arrays. And perhaps most importantly, for unlocking the power, arrays have many of the functions implement a functional programming model that makes heavy use of lambdas. We're going to dig into that because once you understand that, then you're basically, it opens up the door to performing all kinds of different interesting processing using these array functions. So with that, I'd like to dive in, and as this talk proceeds, we're going to look at things essentially sort of through use cases where we work examples, so you can kind of see the features of arrays in action, as opposed to just, you know, sort of presenting the syntax and letting you figure it out for yourself. So the first thing we want to do is use arrays in a way that is pretty common in many databases, which is that you have data which essentially is not a scalar value like 2.5, but instead a vector. So 2.5, 3.2, 6.5, so on and so forth. And here's an example. This comes up when you're monitoring VMs. And let's say you have a bunch of them running in Amazon. You're collecting metric data. And when when you're monitoring the VMs, you have some fixed header information, you know, like when did you do it, you know, what's the ID of your VM, what's its type. But then you start to see, as you dig deeper in, you're going to have a number of types that you're going to have a lot of information that's represented as key value pairs. And so, for example, we have metrics, you know, different types of metrics here. Values for each of them, that's in the metrics name and metrics value, and then tags. If you use Amazon, tagging is standard for VMs, but the tags have a wide range of possible names. In fact, they're anything that you care to make up. So arrays allow you to model this in a kind of straightforward way. So what we'll do is that when we have key value pairs, it's very common to set up a table where you'll have your header values as scalars, and then you'll use paired arrays to represent the name of the property that you're looking at, as well as its values. So for example, for the metrics, which are basically numeric, we have here a metrics name, so that gives us an array of the names, and then in exactly the same order as the names, a bunch of floats that give you actual values. And then for the tags, we do the same thing. The only difference is that in Amazon, tags, their value is a string typically. Other than that, we're using standard syntax for ClickHouse. So we use the merge tree engine, partition by date, do order by. These are all things which, if you're familiar with ClickHouse, they're standard for setting up tables. Let's have a look at how this actually works though. So one of the first features of arrays that you'll run into is something called an array join. And what the array join does is it allows you to take those arrays, which are present as stored as full vectors in the column, and actually unroll them and turn them into simple, back into key value pairs again, that you can process in a tabular manner. So here we have, what we're doing here is we're selecting the header names, and we want to look at tags here. So what we're going to do is we're going to take those tags array and we're going to use array join so that we will actually join on the tag's name, and then that will turn out, as you'll see shortly, as you'll see from the picture, turn out to be a name column and a value column. And what this does is basically for every value in the arrays, in the array or arrays, we're going to repeat the header information. So that's exactly what you see happening here, that the first 3 columns are header information, and they are repeated for each, for each set of values in the array. And the interesting thing about this is the arrays are all unrolled together. That's a very powerful feature of this. But what it does is it turns it into a table. And at this point, now that we have this table, we can do normal SQL things on it. For example, I don't show it here, but we could select all the machines where there's a name. Or we could even do things where we could look for machines that aren't tagged. So we can join this information with other types of data and look for untagged machines. We can look for machines that belong to particular groups like marketing. We now have an enormous amount of flexibility because we can take these arrays and pop them into forms that are easier to deal with conventional SQL. So this is a powerful feature that we're going to see again and again in the processing of arrays, where you have something where the results contains perhaps some scalar values, plus they contain some vectors, which are also in the row, and the array join allows you to unroll them and turn them into a nice tabular organization. There's a question here, isn't array join similar to the explode operation from Hive SQL? I actually haven't used that, but it sounds, just from the name, it sounds very similar. So, so the answer is probably yes. And one thing that I think is important to note about this is most databases that I've looked at do have, that have arrays, have some feature like this that allows you to do this kind of interpolation. All right, so we have some questions coming up, but I'm going to take some of them later on. So just hang on a minute and we'll get to them. Now, one really important thing about joining arrays is ClickHouse actually has 2 ways to join them. So there's the array join syntax that I just showed you, and then, somewhat confusingly, there is the array join function. And this essentially does the same thing. It does this same interpolation operation, but it has an interesting property that you should be aware of. So for example, on the left side, I show a very simple example where I select 1 and 2. I'm going to do array join on this vector, which has A and B, and it has pretty much the same effect as using the array join syntax I just showed you. What's interesting though is if you combine them, like if you have more than one call to this function in the same select, you'll actually end up doing a Cartesian join. Sometimes this is what you want to do, but a lot of times in arrays, this is not what you want. So the behavior here, you need to be aware of it. It's slightly different from the full array join syntax. Anyway, that's a feature. You can use either one. We use array joins heavily in our processing, as do our customers. Okay, so that is the basic, sort of gives you an introduction to the basic array features. But what we now like to do is dig into some of the behavior of arrays where they become quite different from features available in other databases. And I'm going to talk about 2 functions, one called group array and another called sort array. And just to cue this up, I'd like to just offer a problem that we want to look at that will give us a nice opportunity to show how arrays can really work. And one of our favorite data sets is airline on-time data. So we have about 175 million rows. This is commonly used to, as a pet data set to show ClickHouse capabilities. And we're going to take this data set and we're going to ask what's the highest number of flights per day for a single aircraft. The data set is actually arranged every time there's any airplane, commercial aircraft travels from point A to point B, there's a record showing where it came from, where it went to, and time of departure time of arrival, etc. And so what we want to know is how often do do these, for a single plane, how many places do they fly in one day? Well, this is a picture of Southwest 737-700. It turns out, if you're a Southwest customer, you know that they fly a lot of places. Let's go ahead and dig in and see how we find that out. So the first thing we want to do is just kind of start easy and just figure out, okay, for a given airline or for a given airplane, and that tail num field, that's the tail number of the airplane, so that's an identifier. How many hops, what's the maximum number of hops that we can find in a single day? So here's a query that gets that. We don't need arrays to get this because this is just standard group by and order by behavior, but this tells us that there is an aircraft with tail number N963WN and it has 7 hops. That's the most that we can find on this particular day. So, excuse me. So we have a sense that we're going to see something that has 7 hops, but what we'd really like to see is what's the itinerary. For this, we're going to have to do a little bit more work. And before we go into that, I'd like to introduce another major function which really allows you to use arrays very easily within results. It's called group array. And group array is, you can think of it as a gateway between groups that are generated by the group by syntax in SQL and values that are outside the grouping columns. So I don't know about you, but sometimes SQL, if you don't have window functions, which ClickHouse does not have, it's difficult to process the values that are outside the grouping columns, or a column that actually has an aggregate on it. What this group array does is allows you to pick columns, and basically the arrays will be populated by any of the column values that are found in the group. Moreover, all arrays that you mentioned will be populated in the same order. So in this case, we're grouping by a couple of columns, and then we have a couple of arrays that take additional columns, and this will just grab the values. At the end of this, these guys will be in arrays. So this allows you to take a normal SQL query with a group by and have it now generate arrays that we can then process further. So this is a fundamental function, and one that you'll use all over the place when you're processing with arrays. So at this point, we can start building up a list of stops that our airlines are taking. So here's an example. I've added the group array. So we're still selecting the carrier, the tail number, the flight number for a particular day, and we're doing our order by and group by. That's the same as before, calculating the number of hops. But what we're also going to be doing is using group array to pull in departure times. And what this allows, if we show the results down below, now instead of just seeing the hops, we can actually see a bunch of departure times. And so we've got all 7 records, and they're folded into this array. Now, this is not super useful for actually understanding the itinerary, because first of all, these departure times aren't sorted. The other thing is we can't see where we went. So that's something we're going to have to extend that to basically sort them and add more data so that we have something meaningful to look at. So what I'd like to do now is introduce another very useful array function, which is called sort array, or excuse me, I got it backwards, array sort, little typo there. So array sort, basically by default, you can stick an array in it and it'll just sort it in ascending order. So here's an example. We take some departure times, sort them, and now they're neatly ordered. Another really interesting thing, though, that you can do is you can add a lambda to this function. And a lambda is a functional expression. And I show 2 examples here. This first lambda, which is in the select array sort X, is just going to reverse the order. So it takes each of the items that is coming from the array, gets put in as X, and we're turning it into -X. So we're basically flipping the value, and that will cause the array sort to be backwards, so in reverse order. Another really cool thing about lambdas is they can actually process multiple values. So what you can do within any function that supports these lambdas is you can have additional parameters coming into the lambda, and then what you can do is add more arrays. And what this one is doing in the second example of the lambda is it's actually adding a second set of keys. And what this says is we've got the array values here, the departures, but here's a set of keys to tell us how to sort them. So 2, 1, 3, 4. And this is telling us basically that we want to support them as order them in reverse order. So with this lambda, it opens up this possibility to play all kinds of games with what arrays do. So let's go ahead and begin to apply that. So now what we're doing is coordinating the array sort. So we have the group array, so we're pulling the departure times. We're now feeding those into a call to array sort, where we're going to take the origins and we are going to sort them in order of departure time. So I think if you're, if you've used arrays before, or you're, sort of familiar with this line of thinking, you can start to see where this is going. We've got the departures now neatly lined up, and we've got the origins matching them in a separate array. We can build this out a little bit. So here's where we build it out fully. We don't just have the departures and the origins, we have the arrival times and the destinations. We complete the query, and then what we're going to do is put it in a subquery and use array join to roll it back out into a nice tabular form. So let's do that. So this we'll not look at this code too much, but just go and see the results. And basically, we now get a nice tabular form, which shows that first flight that we identified, this N963WN, and we see the exact departure times, the exact arrival times, and then the origins and destinations, and we can see all the places that this plane went to, which was quite a few. So, so this is a great example of how the arrays can allow you to solve this problem. Okay, let's do something slightly more complicated. Let's try and build a funnel. So a funnel is a very specific type of processing that's widely used in data warehouses. I'm going to show you a simple example from airlines. Since I have this data set and I don't want to create a more complicated one. So I'm going to ask 3 questions. How many planes are flying each day, say, in a given month? On each day, how many of those fly to Chicago Midway? And then how many of those that went to Midway went to Atlanta in the same day? So you're getting all the flights, you're getting a subset of them, and then you're getting a subset of the subset. This technique, how you solve this, was described in a wonderful talk by Maria Mansurova. It's also given down in the references. She explains how to do this for a different type of funnel problem that we'll look at the end. But let's just dive in to see how this works. So we're going to start with a base query, and what we're going to do is kind of strip out some of the data or the information that we had previously, and we're just going to look at arrivals and destinations. So here's the base query. We're beginning to see things properly sorted. We see the arrivals, we see the destinations, because we want to know where people are going. That's important to solve this problem. So we use array sort, we use group array, just as we showed before, and then we can unroll it and get this nice tabular. Actually, this is not unrolled. It shows the actual arrays. So we get this tabular form that shows us the information. Now what we need to do is add some additional conditions to create the funnel. And to do that, we're going to use a function called array filter. What array filter allows you to do is pass over a set of arrays and apply a condition to them, and then what's returned is all the values from the array that meet that condition. So here's a simple one. Example, we've got an array with some small values, A, B, C, D, E, F, and G. Let's filter it so that we get all the values where the length is greater than 1. So array filter does that. We've got a lambda that says, for every value V in the array, it's return it if the length is greater than 1. Another interesting thing that we can do is we can actually combine these values. So for example, we can do an array filter that allows us to find that only returns the values when the tag is equal to name. So that's the second example. So this is beginning to give us some useful filtering. Moreover, there's a trick here that you can use, that when you filter something, you can get the first value that passes the filter. That's that one in square brackets at the end. So that way we find somebody called Joe, who's the first person that that meets this condition. So with the array filter, we can now begin to add some additional information. What we're going to do is we're going to use the array filter, and we're now going to look for, through our destination array as well as our rivals, and we're going to look first of all to find, okay, is one of these destinations MDW? So that's the first thing we want to know. Did they fly to Midway? The second thing we want to know is if they flew to Midway. So if this MDW array actually had a value, MDWR, then do we see something after it that with a later arrival where they went to Atlanta? So this is saying, hey, they went to Midway, and then we're looking for a later arrival that was for same plane, same tail number that arrived in Atlanta. That allows us to basically compute. We're now able to analyze this, and our results will show us whether the plane went to one or both of these locations. So at this point, we can take that query, which basically processes each of the sort of the flights for each plane for each day, and we can use that as a subquery. And then what we're going to do is just select off it, and we're going to look for we're going to group by day, and we're going to look for the count of total flights on that day, and then we're going to ask, hey, did they go to Midway? So that's our Midway tot. And did they go to Atlanta after that? That's our Atlanta tot. So now you see exactly how many flights there were, how many went to Midway, and how many then went to Atlanta. So this is a very powerful form of analysis, and it is widely used in analytic applications. So we constructed what I would call a flight funnel, but most people on this call are probably familiar with sales or marketing funnels. This is an example actually of the funnel that we use at Altinity. We have contacts, we have leads, MQLs, some market qualified leads, SQLs, and customers. We can analyze these and see how they move from one step to the next using exactly the same logic that I just showed you for the flight data. So this is a really powerful technique. And again, something that you can do fairly easily with arrays. At this point, we want to go even deeper into array functionality, but what I'd like to do now is we're going to take a little bit of a break, and we're going to talk about functional programming in ClickHouse. And for that, I'd like to invite Alexander Zaitsev to come on board and tell us how it works.
Yeah, thank you, Robert. Thank you very much. Hi, everybody. I will speak for the next 5 or 10 minutes about ClickHouse functional programming. ClickHouse is often considered as a database for developers for a variety of reasons, and one of the reasons is the very rich functionality for functional programming geeks. And this is all built on top of arrays. If you're familiar with functional programming, you know that it typically manipulates with lists, right? Lisp is one of the first functional programming languages. It's all built on top of lists. In ClickHouse, we have arrays. And there is a classic set of functional programming functions that is also supported in ClickHouse. I mean, array filter, and array filter. Map is supported as array map, and ClickHouse has a little bit limited implementation of reduce, which is called array reduce. From functional programming perspective, those are functions, those are higher order functions because they accept another function as an argument. And you already saw some examples when we used lambdas for filtering and for some other operations, but this is generic approach. There are many functions like that. It's not just filter, map, and reduce. There is also array exists that accept lambda, array first, another way to look in arrays. Array sort that may accept the custom lambda that will provide you the sort order, which is probably not default. And even array sum that can generate sum of your array elements may also accept lambda in order to do some modifications before you sum your data. So it's interesting that ClickHouse can accept multiple arrays as arguments and use them in as a tuple in order to construct a tuple and then use it in a lambda functions. So let's look at a couple of more examples. Probably the simplest implementation of map, or the use case of map function, is to do certain transformations from one data type or one column to some another column. So in this case, for example, we calculate substring of array of strings, substring of the length of 4, right? This is very, very basic. We can also provide the length of substring as a separate parameter. As you can see in the bottom example, we have two arrays, one array of string, another array of string length, and we apply this using this map function. We calculate variable length for every array element. This is very, very powerful function. So let's go to the next example. ClickHouse has many different functions that help you to manipulate arrays, and sometimes they accept lambdas, sometimes they not. If you look into ClickHouse documentation or even ClickHouse system.functions system table, all the functions that start with array, you will find probably 50 or 60 different functions that all do quite of interesting stuff. Here are a couple of examples here. You can reverse array, you can sort array, you can enumerate array that will generate your indexes. This may look weird, but it may be useful for certain calculations. You can do some searches. So array first index will help us to find a string that element of array that matches the condition, the index of element, and so on and so forth. Next slide, we will look into weighted sum. So how we can calculate the weighted sum of array elements. And certainly you can do it with array map and array sum, as in the top example. So we first we calculate, we multiply two vectors using array map, and then we just sum a vector together in order to calculate sum. But as I mentioned a bit earlier, array sum also allows us to use lambda, and if we use lambda expression in array sum, we can calculate it in a single function call. So in a one call, we already calculate the weighted sum, which is very concise and very effective. Next example is array reduce function. For probably for a couple of years, it has been undocumented at all. That was kind of weird. It existed, but it has been added into the documentation probably a couple of months ago, or at the spring, the earliest. And what it does, it allows you to apply aggregation function to an array. So in this example, we can calculate sum of array elements using array sum function, but at the same time, we can use array reduce and apply sum function to array elements. It's not a precise equivalent of reduce function in functional programming, because it doesn't allow you to specify initial element, for example, and it doesn't allow you to specify the custom lambda function. And this is something that we are going to add. But even with this functionality that allows you to provide any aggregation function and apply it to array, and ClickHouse, by the way, has several dozens of different aggregation functions. Even at this form, this is very, very convenient, and it's also very efficient, that we can see on the next slide. So apparently, array reduce is vectorized, and it can execute in parallel. So in this example, I can calculate a sum of 10 or 10 billion elements with array sum function, and it takes a bit less than a second. But if I use array reduce for the same exact purpose, the query time is reduced 3 times. I also played with some other examples that are not shown here, but in some cases, array reduce may provide even 10 times or 100 times better performance, and thanks to better parallelization on all the layers. Next slide. Excuse me. This is quite an interesting example. I wonder if, Robert, you can take it.
I will.
Yeah.
Yes. So this is, thank you so much, Alexander. So with what we've shown you so far, you know a lot about how arrays work, and in fact, if you've done functional programming, it's probably, and you're just new to this, it's starting to dawn on you, okay, you can do a huge amount of stuff here. And so in the spirit of, we don't know when to quit when we're ahead, we're actually going to work an example that uses some of these capabilities to do interpolation of data values. So let's take the example. I've generated some very simple test data here, and so these are, let's say that these are temperature readings. They're being taken every hour, and what we see in this handy bar graph is that we're missing values. So there's just a bunch of values, in this case about 5 of them, which are 0. So that doesn't mean that there was no temperature at that time. It just means the sensor didn't get it, and we don't have a report. So what we would like to do is fix this, and the obvious thing to do is to do linear interpretation from the value before and the value ahead, and put like a you know, sort of assert a value which will then at least give us a sense of what the temperature profile looked like. So let's go ahead and do that. And this is where arrays get interesting. This particular query, I can tell you from personal experience, took me about an hour and a half to set up. You generally, you know, just as a programmer, you know, speaking as a programmer or a coder, you start simple and then you just add more and more and more stuff. Let's just go through what this is doing. So basically, we're using group array, and as we discussed before, to we're grouping by day. So for this particular sensor, and it turns out there's only one sensor, so I don't need to add additional things to group by. But we're grouping by day. We're going to pull the readings for the day into a date time A array. We're going to pull the temperatures into an array called temp A. We're going to get the length of that array, and it turns out we're going to need to reverse the temperature array because we're going to have to search it 2 ways, going up and going down, to find the nearest values to our missing values. So the next thing that we're going to do is, it's kind of helpful to have a list of the indexes to the array. So we'll use this handy function called array enumerate. What that does is it just returns us a list of the indexes 1, 2, 3, 4, so on and so forth. And now we need to find the higher value and the lower value from the whenever we have something missing. So we're going to use array map for that. And the first one is fairly easy. We're going to find the first value above the one we're looking at that is non-zero, and that's non-zero basically. So that's what that, for each temp A, find the first case such that, you know, if you're familiar with manipulating indices, this seems fairly straightforward, and this is actually not a hard query to understand. You can see the condition in the array first index. We're looking for S, where that index value is greater than the I that we're reading in from the array, and then temp A at S is greater than 0. So a very simple condition, and this lambdas are great for this kind of thing. The next one is harder, and the reason for that is that ClickHouse has functions to search arrays forwards, but it doesn't have any to search it backwards. So what I had to do for this was actually go through it, use a trick where I reverse the array as I did above, and then basically I use the same indexes, but I then need to invert the index values I find. It is, believe me, it's easier to say this than it was to do it, but it gives you a sense of that you basically can do practically anything, that any SQL expression that's legal, you can put it into the Lambda, and so you can do very complex processing. And then once we've got the upper and the lower values, finally we're going to create an array which is a map from the original temperatures that are in temp A to temp A fixed. And what that does is it's going to walk the temperatures. If the temperature we find in each point in the vector is greater than 0, we're just going to take it. That's that temp AI that we see down at the bottom. If it's not, if it is 0 or 0 or less, we're actually going to do an interpolation operation. So that's basically what we're doing here is basically subtracting the difference in the values and then dividing. So by the size of the gap. So this is it. It's a complex array, or a complex query, but it actually works pretty well. And what we get when we go back and stick it into our into the array join is we're now going to get we're going to have the fixed values, and as you can see from this, they are nicely interpolated, and we now have a full temperature profile. So this is a very simple example of the possibilities that open up when you use the full power of the arrays, including the functional programming capabilities. And there's just like arrays are used in a huge number of different places. And so at this point, we're almost done with the talk. So I'd just like to summarize a little bit, and then we'll spend some time answering questions, which I hope you have plenty. So just some wrap up of the concepts that we applied. So the arrays, like many databases, ClickHouse can use arrays to model any place where you need to store vector inside a row. And in fact, because the arrays can be pairs, key value pairs, you basically are able to have effectively model matrices. The array join is really important because it actually allows you to unroll the arrays into rows. So a lot of times you'll do operations on arrays and then you use array join to unroll them again to put them back in a table, and we saw a couple examples of that. The group array is the gateway that gets you takes grouped data and basically pushes it into arrays so that you can begin to do window-like processing on it. And we saw, of course, several examples of that. That's helped by the fact that you have this huge library of array functions. Moreover, because they support this functional programming model with lambdas and with the ability to have multiple arguments, there's like a huge universe of problems that you can now solve with this. One thing I want to be clear about is we've just touched on what arrays can do. As Alexander said, there's 50 or 60 array functions. There's also, of course, with lambdas, that, given the fact that it's, you have the full SQL expression capabilities, just an enormous amount of things that you can do. So if you want to find out about those, here's 3 suggestions. First of all, the ClickHouse documentation. In general, the arrays are well documented. As Alexander noted, there's a couple of exceptions. There is a wonderful talk that I already referenced by Maria Mansurova at Yandex, and she walks through the example of a marketing funnel on a website, which is kind of the canonical example of funnel analysis. Her talk is great. It was from 2017, but it's still valid today. And then finally, we have a very interesting article on the Altinity blog. We have, as some of you may be aware, we've been doing some comparisons with Redshift with the help of one of our customers, and who's also interested in this. And one of the ways that you can get really unleash ClickHouse performance is by using arrays. So we have examples in that article that show where you can get cases where ClickHouse on the same data just by using arrays can take shortcuts that allow it to process things 100 times faster than Redshift. So arrays, in addition to being very versatile and allowing to solve you problems, they're also a gate, sort of a way to get very, very high performance in data processing. So with that, I want to say thank you. We'll continue to answer questions. I'm going to launch the poll. So if you don't mind just filling that out, and then if you have questions, we'll stick around to the top of the hour. While you're filling out the poll and thinking about other things to ask, we are hiring, so Altinity is building, and then give you some references. If you have questions about this, feel free to email me. ClickHouse code is located on GitHub, ClickHouse, and of course there's ClickHouse.tech documentation. And I just want to put in one more little plug. We have a cloud platform, which we just officially announced last week. And so if you're in the cloud, particularly Amazon, and want somebody to run ClickHouse for you, we're at your service. So with that, I'd like to open it up for questions. And Alexander, do you have any questions that you'd like to go ahead and answer live?
I have answered a couple of them already. I just want to add that in this talk, we mostly covered how you work inside arrays. So we converted data into array and did some calculations, but it's worth mentioning that you can also manipulate with arrays. And for that, ClickHouse has special combinators like for each and array. We didn't discuss them, but it was mentioned for complete picture. And also ClickHouse has some very interesting functions that work on arrays, but provide some special behavior. For example, we were talking about funnels, but ClickHouse has a window funnel function already that does some array processing and might calculate funnels as a result. Similar about retention. ClickHouse has a retention function that also produces arrays as a result, and it allows you to do some more complicated analytics. We didn't discuss those. We focused in this talk. We focused solely in how to use arrays and functionality of arrays themselves. But probably in some of next webinars, we can talk about some advanced ClickHouse functions that also use arrays, but they actually bring its own logic and its own behavior to them.
Alexander, we have a couple questions coming up. I think the first one, where's Airline located? I know we have our own private copies of it, but I think it's documented on the ClickHouse .tech site as well.
Yes. Yes, if you go to the, I think it's a part of the quick start or something, the airline data, it literally takes probably 10 minutes to set up, including downloading from the internet. It's a public data set, it's easily available.
Yeah, that's a great one. And let me take this next one. So is it possible to present the array element vertically and not horizontally? So I want to clarify what the question you're asking here. I'll interpret it the way what I think you're asking. So it sounds like what you might like to do is take the columns or take the values in the array and flip them so that the array becomes a column heading, that value becomes a column heading, and you just see them sort of as a bunch of values. This is called pivoting, if that's what you're asking about, and ClickHouse does not do full pivoting. The only way that I know how to do it right now is you actually have to pull the data back. You do the query and you'll pull it back into something like pandas, and pandas can do a full pivot of, to turn like rows to columns kind of thing. So if that's what you're asking, that's not something that's directly supported. As far as presenting things vertically, we did show you the array join, which is essentially where ClickHouse takes the arrays and is going to explode out based on the array values, match them with the headers, whatever your group by columns are, and present that in a tabular format. ClickHouse does that very well and very quickly. Let's see. Alexander, here's a question. Suppose I have 3 arrays, X, Y, Z, and I want to return the X values on the condition. And the condition is Y greater than 5 and Z greater than 9. How to combine these 2 conditions into one?
Yeah, I will probably write an example right now. It's very simple. Here we go.
Great. Let's just go back over a few of the existing questions. We can, if you want to type more, feel free. And we will. Oh, looks like here's one that actually I think is an important point. Why group array groups data in a random manner? And Alexander has the answer. The order is non-deterministic as for all aggregate functions. That's a really important point. So you can never, with ClickHouse, you can never count, even if the part is sorted, you can't count on the values coming back in order because ClickHouse might be reading multiple parts when it returns your array. So you just don't know what's happening under there. And but one thing that is important to understand is that group array, if you have multiple group arrays, they will feed the values into the array in the same order for all arrays. So overall, the ordering is non-deterministic, but whatever order it picks, it will use the same row order for all of the array values. That's why we can do these tricks where we go ahead and use array sort and use one of the arrays as a key, because all the other arrays are actually ordered the same way. So this is, that's a really important point. I just want to enlarge on that. We have a couple more questions. Is ClickHouse array join everything? Let's see. Is ClickHouse array join everything then aggregate? Oh, so here's Alexander, do you want to take this one? Is ClickHouse array join doing the join then aggregating, or is it aggregating while doing the array join? So, and the question is to whether, you know, because the latter would have a better memory capability or better memory properties.
I think it depends on the query plan, but if you have let me think. So it really depends on the query plan. ClickHouse tries to be memory efficient, but Etienne, I can't say. I don't have a generic question on that. So we can consider that ClickHouse tries to aggregate first and then do any joins, as it does in other cases, unless you explicitly use some columns that are returned by array join in your some filter conditions or whatever. So it's as simple as this.
Great. Let's see if we have any further questions. I think we're running out of questions and we are coming close to the top of the hour. If there are any further questions, please go ahead and submit them. We'll stay for another minute. Just looking through the questions that you already answered, array of arrays is possible as a column type. We support that. Yeah, and so definitely the array filter, we talked about the multiple conditions. I think we've had a couple questions on that. The lambdas, I think if you understand the lambdas, you're really, and the way that they work and the way that they assign the values, the arguments into the lambda, you're basically 90% of the way to understanding what you can do with arrays. Everything else follows from that, I think. So let's see. I think that is it. So at this point, I'd first of all like to thank Alexander Zaitsev for participating in this presentation today. He gave most of the examples come from things that he's been working on. So thank you very much, Alexander. It's a pleasure to present with you.
It's been a pleasure as usual. Yeah.
And I'd like to thank everybody on the call. I hope this was useful. If you have more questions, don't hesitate to contact us. Read our blog, check out the Telegram channel, the community Slack channel. All these sources are places that you can go and also find out, ask questions about arrays and find out about them as well as more ClickHouse features. So with that, we'll call it a day. Thank you very much. Everybody have a great day. Talk to you soon.